Again, we start the expert system, right? So expert system এ previous ক্লাসে যেটা আমরা দেখেছিলাম সেটা দেখেছিলাম যে what are the different benefits of the artificial experts and the human experts, what are the advantages and the corresponding disadvantages and all those stuffs যেগুলো আমরা দেখেছিলাম। সো তাও আজকে যেটা দেখবো সেটা এক্সপার্ট সিস্টেমের আরেকটু ডিটেলসে, যে এক্সপার্ট সিস্টেমটা কিভাবে কাজ করে, রাইট? কিভাবে কাজ করে, বিকজ দ্যাট অল আর দ্য নলেজ বেস সিস্টেম। সো আমাদের কি থাকে যে যে কোনো এক্সপার্ট সিস্টেম কাজ করার জন্য ধরো একটা করসপন্ডিং ডোমেন নলেজ থাকে, ডোমেন নলেজ, এবং এর কি থাকে বিভিন্ন রকম ফ্যাক্টস থাকে, and as well as there are some rules, এবং এই ফ্যাক্টস অ্যান্ড রুলস গুলোকে নিয়ে আমরা কাজ করি, এবং এই জিনিসটাকে নিয়ে কে কাজ করে? দেয়ার আর টু থিং, ওয়ান ইজ কল ইন্টারপ্রেটার, এখানে আমাদের ইন্টারপ্রেটার থাকে, অ্যাজ ওয়েল অ্যাজ এখানে কি থাকে আমাদের শিডিউলার থাকে, এবং এই জিনিসটাকে আমরা বলি ইনফারেন্স ইঞ্জিন, that is called inference engine, and এই টোটালটাকে আমরা যেটা বলছি that is called knowledge based system, that is called, you can say, knowledge based system, that is called knowledge based system. Like prologue is a language, আমরা প্রথমেই বলেছিলাম যে the thing is that there is prologue and as well as lips, there are two languages যেগুলো আমরা সাধারণত ইউজ করি। সো সেই ক্ষেত্রে আমরা কি করি, এই পার্টিকুলার ডায়াগ্রামটাকে ফলো করি, মানে প্রোলগের ক্ষেত্রে কিছু ফ্যাক্টস থাকে, কিছু রুলস থাকে, এবং দেয়ার আর সাম ইন্টারপ্রেটার অ্যান্ড শিডিউলার যারা কি করে এই ফ্যাক্টস অ্যান্ড রুলস গুলো নিয়ে কাজ করে। সো হোয়াট উই ক্যান সে, that is programmable logic, that is the language that is called prologue, that is, একটা knowledge based system, that is nothing but knowledge based, you can say, system, and we have to specify the facts and rules in the prologue program. So actually কি করতে হয়, that we have to specify the facts and you can say rules in the prologue, in the prologue program, and there is an inference engine in the prologue compiler that will decide what rules must be executed and in what order to get the answer of the query. That means there is an inference engine, there is an inference engine in the prologue compiler, that will decide, that will, you can say, decide that what rules, what rules that must be executed, what rules that must be executed, and in what order to get the answer, get the answer of the query, to get the answer of the query. And the thing is that, so of course, there are some characteristics of the corresponding expert system, you can say, like in you can say, in case of like human experts, what we know, there these systems use rules of heuristics to find the solutions. they can make mistakes but have the capacity to learn. So in that particular case, the knowledge is an expert system is organized in a way that separates the knowledge about the problem domain from the system's other knowledge. Like a general knowledge, we know that how to solve a problem, and knowledge about how to interact with the users. That means there is a collections of domain knowledge, and depending on the domain knowledge, the inference engine that will tries to solve the problem. Prologue আমরা কি করি, we have to just feed some facts, and as well as we have to feed some rules. So in that case also আমরা কি করি, বিভিন্ন রকম প্রোলগের ক্ষেত্রে বিভিন্ন রকম ফ্যাক্টস দিয়ে দিই, বিভিন্ন রকম রুলস দিয়ে দিই, এবং তার উপর ডিপেন্ড করে কোনো একটা পার্টিকুলার জিনিস ফায়ার হয়। সো দ্য থিং ইজ দ্যাট আমাদের অ্যাকচুয়ালি তার মানে যে বেস জিনিসটা হলো যে নলেজ বেস ইন অ্যান এক্সপার্ট সিস্টেম দ্যাট উইল কন্টেন facts and rules. An inference engine that will contain interpreter and scheduler. Interpreter decide করছে what rules to apply to infer new knowledge, and scheduler decide করে the order in which you can say the rules are applied, right? So the thing is that this is the basic thing. That means you can think of that the knowledge, the particular knowledge base in an, you can say, expert system that actually contains facts and rules, facts and rules, and you can say inference engine, inference engine that actually contains interpreter, interpreter, and what we will see, scheduler. What is the task of interpreter? The decides, interpreter that decide what rules, what you can say rules to apply, what rules to apply to infer new knowledge, to infer new knowledge. And in that case, scheduler actually decides the order, decides the order in which the rules are applied. The rules are applied. So the thing is that that is the expert system, and if you know about that, in artificial intelligence there are different knowledge representation system. There are different knowledge representations, representation. There are knowledge representation schemes, you can say schemas, and this knowledge representation schemas, there are four types. That means how knowledge is structured in a program. Knowledge representation scheme মানে কি, কিভাবে নলেজটাকে আমি স্ট্রাকচার ওয়েতে রেখেছি। দ্যাট মিনস হাউ দ্য নলেজ ইজ structured, how the knowledge is structured in a program. And there are some standard set of knowledge representation technique, any of which can be used alone or in conjunction with other to build an expert system. That means what we can say, there are a standard set of this knowledge representations, knowledge representation techniques, knowledge representation techniques, any of which, any of which can be used alone or in conjunction with, in conjunction with others, others to build you can say build an expert system. So what are the thing? First one is a logical representations. Logical representation. That means by using logic, we are expressed the knowledge. ওকে, ফর বিল্ডিং অ্যান এক্সপার্ট সিস্টেম। অ্যান্ড আমরা এই জিনিসটা দেখব, যেটা আমরা বলেছিলাম, যেটাকে আমরা বলছি প্রপোজিশনাল লজিক, যেটা নেক্সট দিন থেকে। অ্যান্ড দিস ইজ ফার্স্ট অর্ডার, ইউ ক্যান সে predicate logic, and there are some higher order, আমরা জাস্ট এগুলোকে জাস্ট বেসিকের জন্য জানা, হায়ার অর্ডার you can say predicate logic, and in higher order predicate logic you can say there are fuzzy logic, you can say there are multiple valued logic, there are lots of logic, there are modal logic, there are temporal logic. So there are different parts of the logic. This is the first one is the logical representations. Second, you can say that is a rule based technique. Rule based technique, you can represent the same thing, expert system, by using these four procedures. The third one, you can say semantic nets. Semantic nets based technique. Semantic nets based technique. And the fourth one, you can say frame based technique. Frame based, you can say, technique. So rule based technique, semantic net based technique, frame based technique. So the thing is that if we already told you that the thing is that the logical representations, that means that would be discussed from the next class, because we go through the details, because that are coming in also gate examinations. Mm, so we will see it clearly, in details. But the rest of the thing are only the semester basis thing, so we are not going details, just for solving the different problems, such that you can solve different types of problem. Mm, so তাই জন্য আমরা জাস্ট জিনিসগুলোকে একটুখানি দেখবো যে কিভাবে কাজগুলো হয়। So the first one, that is called rule based technique. Second one, actually, that is called rule based technique. So so in a rule based expert system, what will happen? The domain knowledge is represented as a set of rules, and that are checked against a collection of facts or knowledge about the current situation. That means, what I'm saying here, that means in the rule based, you can say, expert system, the domain knowledge, the domain knowledge is represented represented as a set of rules, as a set of rules that are checked against, that are checked against a collection of facts or knowledge, facts or knowledge about the current situation. What does it mean? That means when the if portions of a rule is satisfied, that means when the if portion, That means when the if portion of a rule is satisfied, is, you can say, satisfied by the facts. তার মানে if portions of the rule that are satisfied by the facts, you can say the action specified in the then portions is performed, then the actions the actions that specified in the then portion, specified in the then portion is, you can say, performed. Simple as that. That means when this happens, the rule is set to fire or execute. So what will happen? A rule interpreter that will compare the if portion of the rules with the facts and execute the rule whose if portion matches the fact. So the rules actions may modify the set of facts in the knowledge base by adding new facts. That means, you can derive some new facts, you can add to the knowledge system such that by using this knowledge you can derive something else. So the matching of the rule if portions to the fact can produce that are called inference change. Inference change. That means, say I'm taking an example, then it would be more easier to understand. Say the thing is that, say a robot, you have to design this a Jew. So it notices, it, you can say, notices animals. It notices animals, say, having certain characteristics, and certain, you can say, characteristics. Characteristics. So what are the characteristics? So it is unable to identify. It is unable to identify the animals. So what it needs? So it needs. So it needs the help of a rule-based expert system to to identify, right? That means you have to identify the rules. So assume, you can say, there are, say, 7 animals. There are 7 animals such as, say, cheetah, you can say, tiger, say, giraffe, zebra, ostrich, penguin, and, say, albatross. Say these are the different, uh, these are the different animals that are in the zoo, and the robot has to identify that particular thing. The robot has to identify that particular thing. So the thing is that, that means you have to design some rules for that. So say I am designing a rule, say, expert system rules, say, it may be like that, that there are some rules, and you can say, this particular rules is like that. That means this is the rule, and what we know, there is a if part, and if the if part condition is satisfied, then you can identify that is the this. That means, what is this? Say I just write the rules like, rule 1, if the animal, the animal has hair, then you can say it is a mammal. I am designing the robot because robot has no sense. He have to just fire the rule, and depending on the rule, the robot has to identify the animal. So what you have to do? You have to first write some rules. That means if the animal that gives milk, then it is a mammal. Then a robot say the rule 3, if the animal has feather, then you can say it is a bird. So I am just writing the rule, right? So we have to write the rule like that. There should be অনেক rule থাকার কথা, like the animal say flies and it lays eggs, then you can say it is a bird. It is a bird. It is a bird. Say. So the thing is that it may be other rule like that. It may be different types of rules. So the main thing is that the how we can say there may be a cheetah, tiger, there is be uh, lots of thing is there, and depending on that you have to identify, right? uh, I'm not writing all the rules. It may be there may be say the rule 7, because it will be helpful if we show something. The animal is a mammal, and say it has hooves, then you can say that it is an ungulate, and say that can be, say I am written like that, rule 10, if the thing is the animal is a carnivore, and say it has tawny color, and it has, you can say, black, say, strips, then you can say that it is a tiger. It is a tiger. So the thing is that mm, you can say, also you can say there would be some other rule also. I'm just writing the last rule because there may be many rules, because there are lots of animals, so you have to design your own rules. That means the, you can say, animal is an ungulate. It has long neck, long legs, tawny color, and dark spots. Then you can say it is a giraffe. It is a giraffe. So the thing is that since it is a giraffe, so there are actually important ways in which rules can be applied. That means there are different rules are there. So there are two important ways. There are, you can say, two important ways you can say, in which rules that can be applied that can be applied in a rule based system. What are the corresponding rules? The thing is that the first one, you can say, the forward chaining, the forward chaining, and the second one, that is called backward chaining. That are the two things. So in forward chaining, known facts are used to deduce new fact. That means, what is forward chaining? In forward chaining, known facts are used to deduce new facts. The thing is that, like, you can say, uh, a robot that will visit uh, in a, say, in a zoo, they just see some properties, like they will just see something like give meals, and you can say, um, it will has an hoops, you can say, and they will see something like long neck, long legs, you know this tawny color and dark spot, right? So the thing is that, uh, how can they, mm, that means, deduce the fact? There is also one extra rule, say, uh, if the rule is written like that, that will be better. That means, say, rule 8, where you can say the animal is a mammal and it chews cud, then it is an ungulate, and it is even toad. Then what will happen? How the this is the rule 8. How the rule has been, because robot is visit the zoo, and he sees some property. What are the property? They say that gives milk, and they just see the corresponding thing. That means use card. So from that, what they derive, they will go to the rule number R2, and they find that this is a mammal, right? And from that, you can say, they will find this is a mammal, and as well as chews cud, so he can fire the rule number 8, and he fire even toward ungulate. And now you can say there are long legs, long neck, tawny color, dark spots. It sees that particular thing, that means tawny color, dark spots, and then already he derived this fact that eventod ungulate. So from that fact, he derived the rule number 11 they fire, and the thing is that is coming out, that is giraffe. So that is called, you can say, that is called forward chaining. That means we know known facts are used to deduce new facts, whereas in backward chaining, in, you can say, backward chaining, what will happen? In backward chaining, we hypothesize a conclusion. We, you can say, hypothesize a conclusion. আমি একটা conclusions প্রথমে ধরে নিই and use the antecedent. Use the antecedent and consequent rules to work backwards and work backwards. What does it mean? That means আমরা এটা ধরে নিই, ধরো কেমন ধরে নিই, that say animal is cheetah. So animal is cheetah, then you can say uh, I'm not written animal. If the animal is tiger, then we can fire some rules. You can say animals is tiger. Then the rule 10, you can say animal is tiger. I am taking the hypothesis. That means in that case, I am firing the rule number 10. So rule number 10, we already know that rule number 10, that should be carnivora, there should be some tawny color, and there should be some black strips. That means in that case, you can say carnivore and as well as tawny color, and you can say that black strips, right? This is, you know, black strips. So from that, you can also fire the property of the carnivore. So if we say this is a rule number 4, I am written here, but if I have to write something other than that, that means we know for carnivora it should be mammal, it eats meat, and pointed teeth, claws, eye pointed forward. So by using this color, that means I am just guessing one, and we know that for carnivore there are some property. That means, and by seeing this property, I am deciding the thing. That is the basic difference, right? So that is the thing that I want to say, that also you can break this. That means rule R1 and R2 you can fire there. So that means this is in backward chaining. What will happen? We hypothesize a conclusions and you are use the antecedent and consequence rules to work backward. Now the questions may come that when to do forward chaining or backward chaining. So if the goal is to discuss all that can be deduced from a given set of facts, then you have to do the forward chaining. And if the purpose is to verify or deny one particular hypothesis, then do the backward chaining. So the thing is that I think you just understood the corresponding thing. That is one of the knowledge representations technique by using the rule based, right? And also you can do the same thing. You can do the same thing by using semantic net. That is similarly by using the diagram. That means you can say knowledge, knowledge representations. That means knowledge representation, knowledge representation using, you can say, semantic, semantic nets, knowledge representations using semantic nets. So, in that case, the knowledge representation methods that actually based on network structure, based on network structure. একটা নেটওয়ার্কের মতো ছবি এঁকে এগুলো, that means it consists of points or object. It, you can say, consists of points or objects that you can call nodes, that are called nodes, and that are connected by links, that are connected by links, or you can say relationship, that are called, you can say, arcs or edges. So nodes are usually used to represent physical concept, object, or situations. This is same as, when you are doing the object oriented diagram, that is same as that. That means these nodes are usually, that usually used to represent, used to represent, you can say, the physical concept, physical concept, objects, or situations, objects, or you can say situations. An arc, that means the edges, you can say, that shows the relationship between two nodes. That means the particular arcs that actually show the relationship, show the relationship between two nodes, relationships between two nodes. So the relationships are the primary importance in semantic net because they will provide you the basic structure for organizing the knowledge. So without relationship, you can say knowledge is simply a connections of unrelated facts. So with relationship, knowledge is a cohesive structure about which other knowledge can be inferred. So the basic thing is that রিলেশনশিপটাই হচ্ছে আমাদের মেন জিনিস। যেমন ধরো আমাদের যদি বলে দিল, ইউ ক্যান সে, টেক অ্যান এক্সাম্পল, সে দ্য কুইন, ইউ ক্যান সে মেরি is an, say, ocean liner. And the thing is that every ocean, you can say, liner is a ship. So this is nothing but the facts and with no relationship. এখানে আমাদের এর মধ্যে কোনো রিলেশনশিপ নেই। যেমন কুইন ম্যারি ইজ এ ওশেন লাইনার অ্যান্ড এভরি ওশেন, ওশেন লাইনার ইজ এ শিপ। সো এটাকে যদি আমি সিম্যান্টিক নেট রিপ্রেজেন্টেশনস করি তাহলে কি রকম করতে পারি? আমরা শিপ নিয়ে নিলাম, এখানে নিচ্ছি ওশেন লাইনার। So ocean liner, you can say, is a, or you can say a kind of, AKO means a kind of, ocean liner is a kind of ship, and Queen Mary, you can write like that. This is Queen Mary, that is a, or a kind of ocean liner, and this is nothing but, you can say, the semantic net representation, semantic net representation. আগে তোমাদের কি দিত, এরকম একটা আনরিলেটেড ফ্যাক্টস দিয়ে দিত, এবং সেই ফ্যাক্টসটা দিয়ে তোমায় কি করতে হতো, একটা ডিজাইন করতে হতো, সিম্যান্টিক নেট, মানে তোমাদের পরীক্ষায় আঁকতে হতো এই ডায়াগ্রামটা। জি, বাট থিওরিটিক্যাল,
সার্কেল দিয়ে রিপ্রেজেন্ট করতে পারি, মানে ওশেন লাইনারটাকে একটা সার্কেল, মানে তার মানে
না
এভরি
না
ওশেন লাইনার।
না না, সার্কেল দিয়ে রিপ্রেজেন্ট করতে পারো না, বুঝতে পেরেছো? এখানে যেমন প্রত্যেকটাই এক একটা জিনিস আছে, মানে প্রত্যেকটাই এক একটা রিপ্রেজেন্টেশন টেকনিকটা আলাদা, রাইট? মানে যেটা তুমি ডিএফডি তে রিপ্রেজেন্ট করবে সেটা এখানে এইভাবে রিপ্রেজেন্ট হবে না, বাট বেসিক কনসেপ্টটা কিন্তু সেম। তার মানে এই যে রিলেশনশিপ গুলো যেটা এস্টাবলিশ করছে একটা প্রপার্টি, ইনহেরিটেন্স হায়ারকিও দেয়। দ্যাট মিনস the items lower in the net can inherit the properties from the items higher in the net, right? So this actually saves the space, কারণ information about the similar node does not have to be repeated at each node. So instead you can say it can be stored in central locations. Another important property of a net, that is a AKO, that means a kind of relationship that is transitive in nature. That means this AKO, that means kind of a kind of that particular relationship, you can say, is transitive in nature. Transitive in nature is transitive in nature. তবে সিম্যান্টিক নেটে আমরা যদি অনেক কিছু ধরো একটা আমি শিপ নিলাম, আমার ধরো ওশেন লাইনার, ওশেন লাইনার, that is, you can say, a kind of ship. আমি ধরলাম ওশেন লাইনার যেমন আছে অয়েল ট্যাঙ্কার, you can say engine, you can say hull, you can say boiler, Liverpool, say swimming pool, swimming pool, and say this one is Queen Mary. So what we know, that they have different relationship. Like Queen Mary, that is a, you can say, ocean liner, and swimming pool, that has part, that means that has a, swimming pool has a part of ocean liner, right? Liverpool, you can say, is a oil tanker, and oil tanker, of course, that is a ship. And boiler, that has a part of engine, that has, you can say, part of engine. And you can say engine also has part of ship. Simply hull is also, you can say, has part of that. So you can say this is the semantic net for the concept of a ship. এবং এখান থেকে আমরা কিন্তু যে জিনিসগুলো, মানে এখান থেকে আমরা ডিরেক্টলি বলতে পারি, অপশনও দিতে পারি এরকম, ship has part engine, ship has part, you can say, engine, or you can say ship has part, that is, you can say, hull. So that type of thing. From also from semantic net you can also build, you can say, a rule based system. You can also build a rule based system by using, that means, how you can build a rule based system, that means if, you can say, x is a y, then x is a y. So you can build like that. That means you have to build a rule from that. So what we understood, a semantic net that can be used for representing the knowledge structure, and like a uh, inferring from it. There are several questions you can infer from it, like Steve has a part swimming pool, that can be answered very easily from the semantic net. But of course the advantage is easy to insert. You can say about the advantage of semantic net. That means if we talk about the advantage, that means you can say that is very easy to insert. And if you say about the disadvantages, disadvantages, you can say lack of links name standard. There are different type of lack of, you can say, link name standard. And you can say difficult to understand by other. This is very difficult to understand by others. inconsistent labeling, that may be the inconsistent, you can say, labeling, that are the different types of problems when you are using the semantic nets, when you are using the semantic nets. So I think that part is uh, easily, you can say, understandable. So now the thing is that this is called frame based technique. That is not much more, because you just know something, but other than that, that is not so important. So that is called, you can say, frame based, frame based, you can say, technique, frame based technique. So frame based technique, that means in that case, the frames that are used to represent the knowledge. Here you can say that frames that are actually used to represent represent the knowledge, represent the knowledge. So in a frame, the parent of a particular object is given. In a frame, you can say the parent, the parent of a particular object is given. So it will inherit the property of its parent. It will inherit the properties, inherit the, you can say, properties of its parent. So in a frame, the values are given in the slot. So in a frame, the values are given in the slot, given in the slot. So when the value of a particular property is not known, it will call a procedure, right? That means if the value, if the value of a particular property is not known, it will it will call a procedure, it will call a procedure. And here the procedures are of three types. Procedure are of three types: if added, if removed, and if needed. That means when it is required to insert a value, we are calling this procedure if added. When you have to required to delete a value, you are calling if removed. And when it is required to search a value, that means you are calling this if needed. So the thing is that uh, that is nothing but a concept, right? This is nothing but a concept. You cannot do more than that. That means that is nothing but a concept. uh, like mm, these frames actually that are the extensions of the traditional record data type that is used in the database. That means if you choose to program your agent in an object oriented language, then you will have to be able to represent the knowledge as an object, and that object are very similar to the frame structure. That means you can say, as an example of using frames, suppose you can say an agent that is taking a notes at a lecture and wants to decide how much attention to pay and determine any other ways in which it should behave. So what will happen is searches from frames which match the given situation. Like in a meeting of some kind, so it retrieves that particular frame. So in the specialization slot of meeting, that is another frame. Lecture which is more appropriate, uh, you can say it retrieves the lecture frame, that is a frame. ফ্রেমে কি করা থাকে, বিভিন্ন রকম এই যে প্যারামিটারস গুলো অলরেডি লেখা থাকে, আমি ম্যাচ করাচ্ছি কোন ফ্রেমটার সাথে, রুলের মতোই অনেকটা, কোন ফ্রেমটার সাথে ম্যাচ করছে, এবং স্লটস গুলোকে ফিল করা শুরু করছি। স্লটস মানে কি, ধরো কোর্সটার নামটা কি সেটা আমি ফিল করলাম, লাইক ইন দ্য সিস্টেম ইজ, এখানে এআই, এআই হচ্ছে কোর্সটার নাম। নেক্সট স্লট is the level of the course, whether it is a easy or difficult or moderate, এই অনুযায়ী ও কি করবে, রুলটাকে ফায়ার করবে। ইফ ইট ইজ a difficult, you have to pay attention, so the agent begins to pay more attention. The next slot you can say lecturer, that is a frame in itself, so agent retrieves the lecturer frame and they will start filling the slots. So এটা কিছুই না, তার মানে আমার কাছে এরকম কিছু ফ্রেমস রাখা আছে, ধরো একটা মিটিং চলছে, আমাকে পে অ্যাটেনশন দিতে হবে কি দিতে হবে না, দ্যাট ইজ দ্য ফার্স্ট টাস্ক। এবার যদি অ্যাটেনশন দিতে হয়, তাহলে কতটা অ্যাটেনশন দিতে হবে সেটা কি করে বুঝবো, তো সেই অনুযায়ী ও কি করছে, ম্যাচ করাচ্ছে, কি ম্যাচ করে দেখলো, যদি ডিফিকাল্ট হয় খুব, তাহলে কি করবো, পে অ্যাটেনশন বেশি ভালো করে দিতে হবে। তো ইটস জাস্ট লাইক দ্যাট। সো দ্য থিং ইজ দ্যাট, দ্যাট ইজ কল, ইউ ক্যান সে, দ্য ফ্রেম বেসড টেকনিক। সো যে জিনিসটা বলার, যে জিনিসটা বলার সেটা হচ্ছে, আমরা